factorized form to draw inferences about the number. One of those inferences is n a perfect square or not? Or is it a perfect cube? Or is it a perfect fifth power? And so on. So let us start with, if n is a perfect square, what will be the factorized form look like? Right? So how can I visually check that it's a perfect square? If n is a perfect square, I know that n is nothing but square of a natural number. That m itself in its factorized form will be 2 to the power p, 3 to the power q, 5 to the power r, and so on. So square of it, which would become 2 to the power 2p, 3 to the power 2q, and 5 to the power 2r, and so on. So what we notice is, if n is a square, the indices, all the indices or indexes of the prime have to be a multiple of 2. So in this I could say each of A, B, C, and so on are multiples of 2. You could even say even, but since I'm going to do multiples of 3, 5, I'm not using the language of even, and I'm just saying they are multiples of 2. You could even look at it reverse way. It's the same thing. If you have this, that if n is a perfect square, then root of n is a number, is a natural number, right? And root of n is nothing but n is this number, 2 raised to a, 3 raised to b, 5 raised to c, and so on. Root is nothing but raised to half, is a natural number, and this will be a natural number only when a is divisible by 2, b is divisible by 2, right? Because you're taking the half power, right? A raised to 2 raised to a by 2, 3 raised to b by 2 is a natural number, right? I hope you can get it. It's not a very difficult task. And same logic remains for if n is a perfect cube. So now n is a perfect cube. It's a cube of a natural number. So if I take a cube, what am I going to get is the indices are now going to be multiples of 3, right? So all that changes is for the number to be a perfect cube in its factorized form, the indexes of the prime factors have to be multiples of 3. Here I am going to take the cube root. Cube root of n is raised to 1 by 3. So a has to be divisible by 3, b has to be divisible by 3. And if you get the logic out of it, that has to be a perfect fifth power. Fifth power. So if a has to be a perfect fifth power, all the indexes have to be multiples of 5. I'm not doing it out over here. Hope you get the logic, right? An interesting takeaway from this is, what if it is a perfect square and a perfect cube? If it's a perfect square and a perfect cube, they need to be multiples of 2 and 3. 2 and 3 means multiples of 6. Multiples of 6. And what are the multiples of 6? 0, 6, 12, and so on, right? So some of the first few, what shall we say, natural numbers which are a perfect square and a perfect cube is 1. When all the indexes are 0, 1 is a square of 1 as also a cube of 1, or is 2 raised to 6. 2 raised to 6, 2 raised to 6 if you remember is 64. 64 is a perfect square and is also a perfect cube, right? So this is your second number. I should have written a 64 here, yes? Or else it's going to be 3 raised to 6, and if you know 3 raised to 6, 729. 729 is 3 raised to 6, 729 is 27 square, and also 9 cube. You need to know these properties of numbers if you are very strong with, right? Or else 164, 729. These are the only 3 numbers up till 1000 which are a perfect square and a perfect cube. I think that gives a lot of confidence when you know such things out over there, right? And if you want a little more larger number, it will be 2 raised to 12. 2 raised to 12 if you want to check is 4096, or it's going to be 2 raised to 6 into 3 raised to 6. Now 2 raised to 6 into 3 raised to 6 is a pretty large number. Even I'm not accustomed to those numbers, right? So let's leave it. We just got the idea, and we are confident that up till 1000 there are only 3 numbers which are a perfect square as well as a cube, which is 1, 64 and 729. The next one is 4096 if you want to stretch your preparation as such, right? So the factorized form can easily tell me whether a number is a square, perfect, cube or so on. Let's use it in a question. Two very easy examples are, by what least number should 8640 be multiplied to result in a perfect square? You could go into 2, 3, 4, 5, but that's not the ideal way. The ideal way should be you need to factorize it, and when we need to factorize it, remember, don't look at 2, 3 or so on, right? Look at powers of 2. 2, yes. 4, is it divisible? Yes. Is it divisible by 8? Yes. Is it divisible by 16? I would go ahead and even check by 16. 16, yes. 16 5s are 80. 64 left over, it is divisible. So I'll stop over there and I'll say 16 into 16 5s are 80. 64, 16 4s are. And I see a 9 very common out here, or a 27 also. 9, why? Because 9 is a power of 3. 27, perfect. 27 into 2 and a 10. This 10 should have been handled separately. So ideally, I think without going further, breaking further, let me write it here. You should get the factorized form. 2 raised to 2 raised to 4. In just 24, 27 into 2, that's one more power of 2. And this is 10. 10 has one more power of 2. So 2 raised to 6 into 27, that was a 3 raised to 3 and a 5. Again repeat, you should not feel the need of writing this further. Right? This all should be done in your mind as such. If you want, you could just cross check. Now this number, I need to multiply by a least number such that I get a perfect square. And what is a perfect square? A perfect square is where the power of 2 is a multiple of 2. The power of 3 is also a multiple of 3. The power of 5 is a multiple, and so on. So let's see, 2 raised to 6, it is already a multiple of 2. So since I want least number, I'll multiply 2 raised to 0. This will remain a power. But 3 cube, this is not a multiple of 2. I want to make it a multiple of 2. So the least number has to be 3 raised to 1, which would make it 3 raised to 4. And 5 is also, currently the index of 5 is also not an multiple of 2. So I would need to multiply it with a 5 raised to 1, which will become a 5 square, right? So the least number that I would have to multiply is 15 is going to be my answer, right? And this is going to be the square that is going to we are going to end up with, right? Anyway, not a very difficult one, so I'm not going to waste a lot of time. I'll just do one more thing. Again, by what least number should this given number be divided? This time we have just changed, instead of multiplying, we are dividing it to get a perfect cube. Now a perfect cube is, again let me write, has to be, the powers have to be multiples of 3. Right? So I'll not spend so much time. Thankfully this is given out over here. But remember, check, is it factorized form? A lot of people fall for this trick, right? This is not the factorized form. In a factorized form, I just need primes. So the 6 is a 2 into 3. So the factorized form is going to be 2 raised to 8 and a 5, 13, 3 raised to 6 and a 5, 11. I need to divide it by a number, and which need to be as least as possible, such that 2 raised to a multiple of 3. Now 13 is not a multiple of 3, and it is going to be divided, it's going to be reduced, right? Such that I get to a lesser multiple of 3. And what is the lesser multiple of 3? 12. So I would need to divide it by 2 raised to 1. 3 raised to 11. 11 is not a multiple of 3. I want in the end result a multiple of 3, and I'm going to cancel out something, right? So it is going, the power is going to become less than 11, which is a multiple of 3 which is less than 11. That is going to be 9. So I need to divide it by 3 square. That is 9 2s are 18 is going to be my answer here, right? So these are two silly examples. Let us do one tough one.